I told you there's a machine that's part helicopter, part airplane, and completely game-changing. Welcome inside the most advanced tiltrotor factory on Earth.
This is where American military aviation reaches new heights. Let me show you how they build the V-22 Osprey from scratch.
It all starts here, aerospace-grade aluminum alloy. This isn't regular metal. Every sheet is certified.
These CNC machines are cutting with micrometer precision. One wrong move and a $50,000 piece of metal becomes scrap.
Every single part is laser scanned.
Yeah.
The tolerances, we're talking fractions of a millimeter. If it's off, it doesn't fly.
Riveting, old school but essential. Thousands of these fasteners hold the Osprey together, each one placed by hand, each one perfect.
See these? 50,000 rivets in one Osprey. 50,000. And every single one has to be flawless.
Torque specs are critical. Too loose and it vibrates apart, too tight and you crack the composite. The tools know exactly when to stop.
Six Ospreys being built at the same time. It's like watching an assembly line, but for machines that cost over $70 million each.
Carbon fiber wings. Lighter than aluminum, stronger than steel. These wings have to handle the stress of vertical takeoff and high-speed flight.
This material is aerospace magic. It's what lets the Osprey do things no other aircraft can do.
Each engine produces over 6,000 horsepower. That's enough to lift 15 tons straight up.
Check the specifications for the hydraulic lines here.
We need to reroute the main harness before we can connect the blue ones.
All right, let's adjust the crane slightly.
This gearbox is the heart of the Osprey. It takes the engine's power and tilts the rotors from helicopter mode to airplane mode.
Keep it steady now. Easy down to the jig. Roger that. Clear on this side.
Hold steady on the port side.
Clear on starboard.
Alignment shows green, lowering now.
See the corrosion right there at the fastener?
Yes, the subsurface looks compromised. We need to document this immediately.
Yeah. This is where two pilots control one of the most advanced aircraft ever built. Helicopter controls, airplane controls, all in one cockpit.
Lower it slowly. Watch the left side. Almost there. Easy now.
Every hydraulic system is tested under full pressure. The Osprey's hydraulics run at 3,000 PSI. That's 20 times your car tire.
Is the green bundle secured at Station 4?
Almost, just adding the last zip tie now.
We need the continuity check on the red line.
Over 40 miles of wiring in a single Osprey. 40 miles. Every wire hand routed, every connection tested.
Check the leading edge right here near the serial number.
Confirmed. Logging the microfracture now.
Perfect balance is life or death. An unbalanced rotor at 300 RPM would shake the Osprey apart in seconds. Okay, easy now. Bring it down another few inches.
Got the alignment here.
Ready with the first bolt.
Three blades, 38 feet each. When these spin, they generate enough thrust to lift 25 tons. That's the power of Tiltrotor technology.
Lower it slowly. Watch the clearance on the starboard side.
Copy that, easing down now.
Looks good. Keep it steady.
These engine nacelles tilt 90 degrees, from pointing straight up in helicopter mode to pointing forward in airplane mode. That's what makes the Osprey so unique.
Controls checked. Responding normal.
Confirmed. Systems green.
Slow down the crane, bring it down easy.
Watch the starboard side clearance.
We are aligned on the forward pin.
These shock struts have to absorb the impact of a 25-ton aircraft landing vertically. It's like dropping a bus from 10 feet.
Clear on your side. Bring it up slowly.
It's aligned. Ready for the bolt.
Engaging the wrench.
These tires are rated for vertical landings at combat weight. They're not just rolling, they're catching a 25-ton aircraft dropping out of the sky.
We need that starboard engine mounted by 1600.
Copy that. Almost ready for the lift.
This is the brain of the Osprey. Flight computers, navigation, communications, mission systems, all working together to fly.
Seconds, pressure stable at 45.
Confirmed. System is good to go. All right, align it right there. Perfect fit. Let's lock it down.
That was easier than the last one.
Painting a $70 million aircraft isn't like painting your car. Every surface has to be perfect. One speck of dust can ruin the finish.
Check the seam right here, near the engine.
Looks clean. The primer held up well.
Look at that finish. Look at that finish. 3 coats of primer, 3 coats of top coat, and it's not just for looks. This paint protects against corrosion.
Okay, bringing it around now. Clear on the starboard side, copy that. Keep it slow.
Floor bolts secured. Give it a pull.
Solid. Ready for the next section.
Initiating ground power sequence.
Power stable. All systems nominal. Self-test complete.
Both engines are running. Over 12,000 horsepower combined. You can feel the power in the air. We're getting close to first flight.
All parameters in the green, 90% N1.
Solid. No anomalies on the secondary bus.
This is what makes the Osprey legendary. Watch those nacelles tilt, helicopter to airplane in seconds. No other aircraft in the world can do this.
Left wing clear, continue straight pull.
Roger that. Maintaining course.
Rotor group clear, no visible damage.
Confirmed. Tire pressure green, strut extension checked.
Fluids nominal, panel secured.
This is it. Months of work by hundreds of people all come down to this moment. First flight. If everything goes right, this Osprey will be...
Watch your step on the deck plate, sir. Cockpit's clear.
Roger that, Loadmaster. We'll be ready for takeoff shortly. Oxygen system all checked?
Checked.
Harness secure?
Secure.
Before start checklist complete?
Battery switch?
On.
Inverters?
On.
Hydraulic pumps?
On and indicating pressure.
Ground power unit disconnected. Clear for engine start, commencing rotor engagement.
Feel that power! Both rotors spinning, engine screaming, 12,000 horses will lift 25.
Engine temperature is nominal. Rotor RPM 100%. Hydraulic pressure normal. Flight controls checked.
Checked. We are ready.
Three feet hover, stable.
flight complete. From raw aluminum sheets to a flying machine in just months. This is what American aerospace engineering can do. Miles per hour in airplane mode, vertical landings in helicopter mode. The Osprey can do missions no other aircraft can.
The pressure differential is stable across the board.
Fluid levels confirmed on the tablet, Chief.
Good. Let's get the panel secured and prep for the next flight window.
Logbooks are signed off and verified.
Good. All panels check green on the tablet.
Acceptance is approved.
With the signing of these documents, we officially welcome the newest Osprey into the fleet. Congratulations to all involved.
From concept to combat ready in record time. This Osprey will serve Marines for decades, flying missions around the world.
Osprey production doesn't end at delivery. Tens of thousands of spare parts are manufactured to support the fleet for decades.
I need the rotor assembly for the cadenna shipment. It's row 12, shelf 4.
Got it. Pulling it now.
This blade is showing minor pitting. It needs replacement.
Copy that. Log it as unserviceable.
Bolt sequence initiated.
Torquing number 14 now. Confirmed green.
Reading recorded. Next.
Building the Osprey is just the beginning. Keeping them flying for 30 years requires a massive support system. Parts, overhaul.
Ensure the torque wrench is calibrated correctly before applying pressure. Listen for the click. That indicates the component is secured to specifications.
Easy now. Keep the tension consistent right up to the bolt head. That's it. Now give it one more twist and snip the excess clean.
Are the fiber leads secured in the bay?
Yes, all greens across the board. The displays are online.
Technology advances fast. These upgrades keep Ospreys at the cutting edge for decades.
Final bolt tightened on turret 4. Harness is secured. Copy that.
Running system initialization. We have full green status across the board.
The investment in upgrades maximizes the value of the original production investment and maintains fleet capability.
Time's critical. Push the pace on those final rivets.
Yes, instructor. We are setting the last ones now.
This meets the structural requirements. Good work, maintainer. Now, let's move on to the next section.
Ospreys fly into hostile areas where damage is a real possibility. Maintainers train to fix battle damage in the field and get aircraft flying again.
Ospreys returned from service in harsh environments, such as saltwater ocean deployments and desert operations, undergo meticulous corrosion inspection and treatment.
Checklist item 304, hydraulics response.
Receiving full pressure on the primaries, green across the board.
Confirmed. Final certification authorized.
Bell Boeing proudly returns this Osprey to the fleet, fully mission capable.
The Marine Corps accepts. She's ready to fly.
Check complete on the starboard engine.
Copy that. Logging it now.
Clear to start APU.
Go, move out! Clear left! Clear left!
Osprey flying tonight represents the work of thousands of people: engineers, technicians, pilots, maintainers. Each one is a link in the chain.
Mission complete. Long one.
Welcome back, Captain. We'll take it from here.
Thanks. Get her ready for the next rotation.
The approach into the LZ was solid, but we need to refine the timing on the flare drop.
Agreed. We'll integrate that into the next briefing package for the squadron.
From that factory floor to flight lines around the world, the Osprey has proven itself. It's more than an aircraft. It's
Clipper 01 cleared for takeoff runway 27. Ground support, move to Point Alpha. We have inbound traffic.
the Bell Boeing V-22 Osprey. Half plane, half helicopter, all amazing. Thanks for joining me inside